Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question's asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimetres squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line, if I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. To subtract mixed numbers, we must convert them into improper fractions first. So to do that, we do the big number times the bottom and add to the top. So it's going to be 3 times 4, which is 12, and add to the top, which is 15. Keep the bottom the same. 2 times 5, add to the top. So 2 times 5 is 10, add to the top is 11. Now we need to get the denominators the same. So the first number in the 4 and the 5 times table So we just write out the times tables, and we can see that 20 is the first number in both of them. So we're going to times top bottom of the first fraction by 5 and top bottom of the second fraction by 4. So we must have the denominators the same to be able to add or subtract them, in this case subtract them. So when we do that, we get 75 over 20, and 11 times 4 is 44 over 20. Subtract the tops, and we get 31 over 20. This is improper, so we can take away one lot of 20 from the top, which will give us 1 and 11 over 20, and that is actually our answer. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So I'm going to write this question out a bit bigger, just so we've got a bit more room. And we're asked to solve. So what we're going to do with this is we're actually going to start by putting our solving lines in. And we're going to try and figure out what we do to get x on its own. So we're going to start by subtracting 9 to both sides. And so that will leave us with the 10x squared on the left hand side, and then 250 on the right. Then we're going to divide by 10 both sides. So we've got x squared equals 25. And then we're going to square root both sides. Now, this does give us 5, but it also gives us negative 5, because minus 5 times minus 5 is also 25. So our two solutions are 5 and minus 5. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010. And we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. What is it? 990. Now, when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is I want the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. All right. Let's put our solving lines in, and we're going to divide by 8 both sides. So we get x equals 5, and we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47, and then we're going to take away the 15 both sides, and so it's 4y equals 47, take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25, take away 4 times 8, which is 32, is minus 7. So we know we've got it right. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that, we need to work out what the diameter of the circle is. And if you notice that the diameter of the circle is just 40 degrees, it's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So we're going to first of all realise that this is a right angle triangle and we've got 2 lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, Ka, Toa. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals root 3 over 2. You need to know from memory that sine 60 is root 3 over 2. And notice here that the x therefore is going to equal 60. So we're asked to solve f of x equals 23, but it tells us that f of x is 10x plus 3. So all we're really doing is 10x plus 3 equals 23. And we're just doing a simple solve. So get our lines in, and we're going to take away the 3 both sides, which will give us 10x equals 20. Then we're going to divide the 10 both sides, and that just gives us x equals 2. So our answer is 2. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules, to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method, where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides, because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. It tells us in the question that angle OCA is a right angle. So if that's a right angle, it means that OC and AB are perpendicular. If they're perpendicular, that means that x is 5 centimeters. And the reason for that is that the perpendicular from the center bisects the chord. And what that means is that we've got a perpendicular from the center, which is this line here, and we've got it hitting a chord, and a chord's just a line across a circle. But the key word here is bisects. What bisects mean is that it will hit it halfway at the midpoint. So if it's at the midpoint, that 5 centimeters will equal the x. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So 2 over 11 is the same as 2 divided by 11. And we can do that with a bus stop. So if I just do a bus stop down here. So we've got 11 on the outside and 2 on the inside. And chance I will we'll almost certainly need decimals. So I'm just going to put some zeros in. 11 into 2 does not go. So we're going to move that 2 across. 11 into 20 does go 1 and carries the 9. 11 into 90 goes 8 and carries a 2. Hang on, 11 into 20 goes 1, carries the 9. We can see a pattern going on here. 8, carry the 2, and 1. So you can see that this is just going to keep going on forever. So 2 divided by 11 is 0. And the 1 and the 8 are just repeating forever. And the way we show that is with a dot above them. And so when comparing this to the bit in the question, our x value will be 1 and our y value will be the 8. So we're going to start off with the middle here, and then we're going to make our way to the right, and then we'll make our way to the left. So we're going to start off with 11 to the power of 0, and that's going to just be 1. Anything to the power of 0 is 1. Then we're going to do 11 to the power of 1, which is just 11. Anything to the power of 1 is itself, and then 11 squared is 121. Now this next one here, 11 to the power of minus 1, whenever you have a negative power, you just put 1 over 11 to the power of 1, or 11. Same with 11 to the power of minus 2, 1 over 11 to the power of 2. 11 squared is 121. So that would be 1 over 11 and 1 over 121. Okay, so this is not going to be too easy to plot because it's so difficult to get them low down, and we'll change the colour just to make it a bit easier to see. These are essentially going to be at the bottom. This goes up to 11, so you can see that a little bit more, and then we've got 121, which will be there. Okay, so whenever you draw the curve, it does help you sometimes to turn your page sideways. I can't do that, unfortunately, but I will try my best. And you want just one smooth, continuous line. And I've kind of dipped a little bit at the end there, which I didn't mean to do, but any of these graphs will give you full marks. You need to make sure that it's one continuous line, that it goes through all of the points, and that you don't do any feathering like that. It's just one smooth line joining them up. So we know that frequency density is proportional to frequency over class width. And so looking at this first bar, we've got a frequency of 12, and the class width is 10 wide. So the frequency density you would think would be 1.2, but if we look at it, it's actually 0.4. So we know that we're going to have to divide it by 3 to get there. So our formula is frequency density is the frequency divided by class width divided by 3. Okay, and so to find the next one, to find out what the frequency density is for the next one, we're going to do the frequency, which is 36, divided by the class width, which is 10, and then divide it by 3. And so when we do that, we get the answer of 1.2. And then we're just going to do the same with the next one. Frequency density is going to be the frequency, which is 12, divided by the class width, which on this one is 5, divided by 3. Then when we then do that, we get 0.8. So we're going to plot these on. So our next one is 1.2, so that goes up to 1.2. And then the last one's 0.8. So the frequency is kind of equal to the frequency density times the class width. And I say kind of because it's actually a proportional relationship. The frequency density doesn't have to be that value, it can be twice the value or half the value. But we're going to assume it is because we can check whether it is by the value given to us in the question. So going through each of the groups, the first one is 0 to 10 and it has a frequency density of 0.2. So we're just going to do 0.2 times 10, which will be 2. The next one has a width of 20 and the frequency density goes up to 0.8. So 0.8 times 20 will be 16. And the last one is a class width of 20 and it goes up to 1.2. So we're going to say that that frequency is 24. So if you do 24 plus 16 plus 2, you actually do get to 42. So we know that that is frequency equals frequency density times class width. Okay, now it says to estimate the amount of rocks that were greater than 15 kilograms. So we're going to draw a line up from 15 kilograms. And we're looking for all the values that were to the right of that line. So we know that there are 24 definitely, okay, because all of that bar is to the right of that line. And we've just got to work out what proportion of this bar is to the right of that line. Well, it's 4 squares wide and we're looking at 3 of the squares. So it's going to be 3/4 of 16. So the amount we're looking for, so rocks, is going to be 3/4 of the 16 plus the 24. So the 3/4 of the 16 will be 12 plus the 24, which will be 36. The first thing to notice is that 125 is 5 cubed, So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay, and then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'll be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here, but we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand Surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. And you'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69. 4 root 2 halved is 2 root 2. And 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So we're going to need to complete the square to be able to answer this question, but the first thing I need to focus on is this 2, the coefficient of the x squared. I want to make sure that x squared doesn't have a coefficient, or has a coefficient of 1. So we're going to start off by just removing or dividing out that 2. And we're going to do it from the x squared and the x term. So I'm going to be left with the x squared plus, and that's 14x. And we just leave this plus 5 at the end. That plus 5 really only ever comes into use at the end. Now we're going to complete the square here. So that will give us brackets x plus half of the x coefficient, which is 7 squared. And I'm just going to expand that quickly here. So x plus 7 squared is the same as x plus 7, x plus 7. And when we expand that, we get x squared plus 14x, which is good. And then we get plus 49. Now this bit here is the bit we need to remove. So what I'm going to do here is just take away that 49, because we don't really want that 49. Close bracket, plus 5. Okay. Now I'm going to expand these brackets and have the 2 next to the x plus 7 squared, and 2 times minus 49, which will be minus 98, plus 5. And then all we need to do now is add the minus 98 and the plus 5 together, which should be minus 93. The m part will be the 2, the p part will be the 7, and the q part will be the minus 93. It's always important with these questions to realise what the normal graph will look like before we have a look at what the new function will look like. So it's always good to remind yourself what a y equals sine x graph looks like. And it fluctuates between 1 and minus 1, if I write a -1, and it goes up first of all at 90, goes back down at 180, down to -1 at 270, and then back up at 360. So it's just a simple sketch to help us figure out what's going on with the transformed one. So first thing I notice is there is a negative here, which just means it will be flipped in the x-axis. So this would become like this. And there's also a 2 there, so we're multiplying all the y coordinates by 2. So instead of this going down to -1, it will start by going down to -2, and it will go up all the way to 2. So we've got a nice idea of how this will look. And so we're going to just start plotting this now, I think. So it will go down at 90, which is, so there, to -2, back up to 180 at 0, and then back up to 2 at 270, down to 360, and then it will just go again, 540, up there, and then back down. Not the best graph I've ever drawn, but I think the examiner will understand that I know what the graph will look like, so don't panic about making too many mistakes when you're drawing curves. Just try your best to get it as low as possible, but don't go back and start feathering the lines or anything. So the first thing to do is we want to find the roots from the sketch that we've got. And the roots are just where the graph crosses the x-axis. So we can see it crosses it here at -8. Crosses it here at 3. Crosses it here at 5. Now, what is special about roots? Well, roots are where the graph equals 0. It's where y is 0. And the only way to get to 0 is, for looking at this, is if one of these brackets is 0. So we're going to say, okay, well, let's have a look at the first one, x plus a. Let's get that equal to 0. Oh, equal to 0. So we're going to put in the first root in there. We're going to say -8 plus a equals 0. Add 8 both sides. A must equal 8. So if a equals 8, then the whole thing will equal 0. That's the first root done. Go do the same with the next one. X plus b equals 0. And this time the root is 3. So it's going to be 3 plus b equals 0. Take away 3 both sides, and you get b is -3. Then we're looking at the last one. X plus c. We'll look at the last root, which is 5. Oh, we're going to get it equal to 0, and then it's going to be 5 plus c equals 0. And take away 5 both sides, you get -5. And so if a is 8, b is -3, and c is -5, it means that at -8, 3, and 5, it will equal 0, which is what it does in our graph. Now you might say, well, why does a have to equal 8? Why can't b equal 8? It can. These can be in any order. And so if I wrote these in the opposite order, -5, 8, and -3, for instance, it would still be correct. Here we've got a half on the outside, so our function's been multiplied by half, and all that's going to do is it's going to halve each of the y coordinates. So we've got a y coordinate here, and half of 6 will be 3. The 3 we've got here will be 1.5. The bottom of the curve here will be at 1, and you just go through and just halve all of the points on the graph. And when you do that, you should be able to draw in the graph, and it should look something like this. We'll try our best to draw it. And we're not looking for it to be absolutely perfect, but looking at that, you can clearly see that all of the y coordinates have been halved. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now, if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.